used WaterGEMS before, so just to give an overview of what it's capable of. And then we'll get into the WaterGEMS for ArcGIS Pro side of the demonstration, which will include quickly going through some symbology and display settings, looking at the output tables and results, both our own flex tables, WaterGEMS flex tables, and also the attribute tables within ArcGIS Pro. We'll also quickly look at the Criticality tool and some of those results within the ArcGIS Pro interface, and also our flushing reports. And then finally, we're going to slow down a little bit for the final topic of the presentation and go into a bit more detail with model creation and model updates using your GIS data. So going forward with our overview, if you're not familiar with WaterGEMS, so WaterGEMS is hydraulic modeling software. It's just a mathematical representation of your real water distribution system, and you can use it across planning, design, operations, maintenance, so really the full life cycle of your system. So the idea is to give you a tool to help you make better decisions when it comes to designing your new system, looking at pipe replacement, looking at supporting operations, and providing better emergency response and more informed emergency response. So we do provide some very nice, friendly interface tools for you to use this software. The screen capture that I'm showing here on this slide is from our standalone platform, but we do support 5 different platforms with the same piece of software, same model files, same license. So in addition to standalone, we support the MicroStation platform, also AutoCAD, ArcMap, and then our newest ArcGIS Pro. And you can see here I've switched the screen capture. This is WaterGEMS running inside the ArcGIS Pro interface. So what are some of the key features of WaterGEMS? Well, one of them we're showing here is a tool called Darwin Designer, which will help you automatically design your pipes for least cost design or to provide maximum benefit, like maximum pressure benefit, or both, a balance between the two. And you can look at pipe rehabilitation options as well through this Darwin Designer tool. So that's one thing we have. Another capability within WaterGEMS is the ability to support multiple scenarios. So scenarios are just different model runs, and so you may want to be doing water quality runs or looking at your system at present day or a future condition, 10 years from now, or look at what it does on a maximum day in the summertime. So really no limit to the different types of scenarios that you can set up and manage within your single model file. And a lot of the idea here is we want to maximize the shared data and data reuse through scenario management. We have a tool to help you identify your pressure zones automatically. So a nice thing when you first create your new model is to come in and run this pressure zone tool, and it will look for things like pump stations and control valves and closed valves, and use that information to identify the pressure zones in your network so that you can get those assigned easily. So we're showing here in the background, you can see a single pressure zone getting highlighted, as we look around the different parts of the system, highlighting the different pressure zones that were identified. We have another new tool, and this one's a fairly recent addition to the software, this district meter areas tool. And this will allow you to specify a target size for a district meter area, and the software will automatically uses graph theory to go through and look for areas of the network with a minimal amount of interconnections between them to identify those as candidates for boundaries of district meter areas. We have another tool called Darwin Calibrator that can help you calibrate your network to ensure that your water model more closely matches your real world situations. So we often adjust pipe roughnesses and demands as part of this process, and so Darwin Calibrator can actually automatically adjust those for you to bring your model into better agreement with your field data. We also have water quality analysis. You can do age analysis, constituent concentration for really any constituent. You can do a trace analysis to trace where the water comes from, which source it comes from. We also support multi-species analysis. So if you have constituents that chemically interact with one another, then you can model those as well. And this is just showing an animation of looking at constituent concentration through time in our network, and the color coding here shows you the concentrations over time as it moves through the system. We also offer connections to your SCADA system, and you can read in that SCADA signal data, either historic data like what's shown here on the graph. We have some plotted points helpful to us in, say, calibration and just making sure our model results sync up well. You can also use SCADA data to establish initial conditions for a model run if you're wanting to do forecasting, for instance, based on what the current situation is in your system. You can also simulate different emergency events. We have a tool called SCADA Connect Simulator with some interface tools just to make that very easy for you. This example here, we're simulating a fire and saying what that fire flow and duration are, and recalculating the model to see what happens. And you can also apply control overrides. So if you wanted to change your controls to ensure a tank recovered more quickly following a fire or something like that, we give you the tools to adjust your existing scenarios with modifications due to emergencies very quickly so that you can see what the likely outcome is and how you might mitigate that best. So we have a number of other features that I'm not going to go through one by one. It would just take too much time today, but you can see here in the list some additional things that we can do. And then I have this second slide as well. And I'll give you just a moment to be able to scan through that. But if you have any questions about any of these features in this slide, then feel free to ask us about it. We'd be happy to take any questions you may have at the end of our presentation today or later on. And now we'll go ahead and move into working with it inside of the ArcGIS Pro interface. All right, so here is WaterGEMS running inside of ArcGIS Pro, and you can see the tabs across the top. We've got the regular ArcGIS Pro tabs, and then followed by a WaterGEMS tab and all these other water prefix tabs that go along with WaterGEMS. I am running right now at a low resolution just for purposes of this online presentation. So normally you would have a little bit more space here and these words wouldn't be cut off on the tab names here when you were running with a more typical resolution on your machine. But I think we can see enough of it to get the general idea here. As far as how we got to this point, so if you're starting out and wanting to do a new water model inside of ArcGIS Pro, or you've got an existing WaterGEMS file that you want to bring into this interface, it's really just you start up WaterGEMS for ArcGIS Pro. There's a shortcut that gets created automatically when you install WaterGEMS, and you'll create a new project file inside of ArcGIS Pro, and once you're to that point, it's just a matter of going to this WaterGEMS tab and going to hydraulic models, and if you're starting from scratch, you would add a new hydraulic model, or if you've already got a WaterGEMS model file, then you can choose Add Existing Hydraulic Model, and that will get brought in. And what happens as part of that process is it will prompt you it will be setting up automatically a new file geodatabase. It'll prompt you for what coordinate system that you want to use for that, but there'll be an automated process where it inserts all of these different layers into your map, a different layer for each type of element that we have in our water model. So you'll see this populate over here with that information. Now, I've done a little bit to my model after that point to make the symbology just a little more customized to how I wanted it to appear. So you'll get some pretty generic looking little point symbols and things like that. But it's very easy in ArcGIS Pro. You're just going to use its symbology functionality to make these symbols look like whatever you would like them to look like. So if you'll just click on one of the symbols, and it'll bring up this window here, and you can choose things like change the style. And you can see I've got some style here that I saved with some of my own types here, but there's a lot of things that come with ArcGIS Pro, or you can make your own. So whatever you would like to do there, but just be aware, you can customize this appearance to however you would like using that ArcGIS Pro functionality. But I'll close out of this for right now. All right, so we'll go ahead and take a bit of a closer look at this system. I do have some zoom-dependent visibility set up here so that as we look a little bit closer, we'll see some additional elements start to pop up here. Okay, so you can see these customer meter nodes here that are shown. It's a little house symbol there with a lateral connecting it to the mains. I've got some isolation valves that are shown here in purple. And actually for now, just to clean this up, I'm going to turn off this pressure labeling that I have on my junction. So let me just disable those labels for now and see those a bit better. And then I also have some water sources here, some reservoir-styled elements with pumps connected to those. And then my junction nodes are showing, well, these are showing up in blue. They're actually color-coded right now based on their pressures. As far as the data that's behind this, let me start first with talking about our flex tables generally and WaterGEMS. We have some default predefined tables in here, which if you've used WaterGEMS, you maybe used. All of these are customizable, and you can create your own tables. But they have, if we open it up here, these are tables that you can customize to contain just the columns that you want, and then you can sort and filter and run queries and all sorts of navigate your drawing using these tables. So it's very easy to do that. There's an edit button here, and you'll get this window with everything that's currently in the table on the right and everything you could put in it on the left, and you just move things around and set up your table however you like. When we're working with either ArcGIS Pro or ArcMap, there's another kind of table that we use called a geotable. In terms of setting it up and its appearance and everything that you can do with it, it looks just like the other type of table. But the difference is that this data can be automatically synchronized with the data in your geodatabase attribute tables. So what will happen is if I right-click and open an attribute table for my junction node, then I'll see a series of columns in here, and this is set up, it will automatically exactly match whatever I've put into that geotable format. So anything that you want to be able to access in the using the ArcGIS Pro tools, so if you're using ArcGIS Pro for color coding or for labeling of your drawing, for instance, or any other type of output results presentation tools, you need to make sure you have whatever fields that are going to be used as part of that present in your geotable, and then it will be available to you here. So in this case, we've already set up some color coding here on our junction. So if I right-click on junction and choose Symbology, we can see where this pressure symbology is already set up. There are some ranges here for pressures that are assigned different colors in the model. We have a tool that helps you do that more easily, and I'll make it for the example. I'm going to go down to the pipes and right-click on that, and what we're going to do is choose Initialize Symbology. And this will launch you into our WaterGEMS tool, where you can select the field that you want to color code by, and this looks similar to our standalone version. But if whatever you're going to select in here, it needs to be in your geotable also. I'll select diameter, and it'll automatically assign some different colors and ranges. And maybe I actually want to make the bigger pipes have a larger line weight, so I'll choose size there. If you wanted to make these even numbers, you could. Or just do a better job with choosing your minimum and maximum and steps that I did. It would have come out more even to begin with, but we'll apply that. And so now when we zoom back out, you can see your network with that diameter color coding all applied. And you can see now how this is showing up over in our contents window. And then if we wanted to make a modification to it, we could do it in here, or we could just redo the initialized symbology for whatever we would like to symbolize by next. Okay, so very easy to set that up. Another thing that we can do is labeling of our drawing. And I already have some labeling set up for the minimum pressure, to label my junction nodes by the minimum pressure. And I'll right-click and choose Label to turn those back on so you can see them. And I'll have to zoom in some because my junctions don't show up until I'm zoomed in here fairly close. Now I'm zoomed in here, you can see the labels there in white at those locations. The way that that was set up, if I right-click and I can go to Labeling Properties, and you just double-click in the list here whatever you want to label by, so it'll find the fields that are available in our attribute table, that's what's in your geotable here for you, and it will write the expression for you based on what you select. All right, a couple of other items of note in the display. I do have flow arrows turned on, so you can see these little triangles on my pipe. So those are pointing in the direction of the flow. That's also a symbol here in the contents that you can change some properties of that. That is, and you can choose whether or not you want your flow arrows to be visible. That's available here under the Water View menu. You can choose to apply them or remove them in the drawing. The other button we have here is Apply Active Topology, and this is relates to whether or not elements are active in a particular scenario. So you may have a model run that's your present day system, and then you may have one for a future proposed extension to your system, and you want to keep both scenarios. Both are valid, but you have some pipes and other elements that are present in your future system that are not present currently. And so we have an attribute that lets you select whether elements are active or not for a particular scenario. But there's also a display component to that. You want to be able to visually tell when you look at your network which elements are active or inactive in the system. So what you need to do is, if you want to be able to visually tell where you have inactive topology, you need to go to this tool and choose Apply Active Topology Symbology. And so now you can still see these elements, but they're kind of ghosted out there. So it's really applying a transparency to any inactive elements. And if we go back to a different scenario where this is actually this new subdivision is part of our system, and make that the active that we're looking at. So now we can see that these pipes are no longer transparent in the model. Okay, we'll look a little bit more at how we can review the results in our system. One really nice thing to do to look at data when you're looking at simulations over time, as this one is to use graphing. And I'm going to go to my Water View tab at the top and choose our Quick Graph tool. It is docked over here in the lower left, and when I click on an element, when the Quick Graph tool is available, it will update with a graph that's showing a property of that element over time. So by default right now it's showing pressure, but I can see I could also look at hydraulic grade or demand over time here with this. And there's a little launch tool if you wanted to launch it to open the full-size graph. And the full-size graphs you could do a bit more with, because you can do things like compare multiple scenarios and compare multiple elements and multiple attributes on a single graph. But for just, casually looking around your system, exploring, trying to figure out what happened, this quick graph tool is a really nice way to do that. So another nice use of these graphs is to help you navigate in your system to a time that may be of interest. And so right now I'm looking at pressure over time at one of these nodes, but I have a little time slider here, and I can drag it to a point in time where I'm at a minimum pressure, and you can look at the nodes in this area, and it looks like we've got some pink nodes here based on our color coding. That pressure range between 475 and about 634 kPa would result in that color. And if I scroll forward in time here, then I get some different colors. So those have now switched to red. Actually, we have quite a high pressure at that point here. It's above 725 kPa, and we see the change there to red. Now, the white labels here for pressure are not changing, and the annotation here is actually for the minimum pressure, which would not change over time. Minimum pressure is taken across all time steps, but my color coding is set up to be the pressure at the current time step, so you will see it vary as you move around through time for your system. So we have just a couple more features to look at before we get into the model building part of this presentation. So first of all, we're going to go look at Criticality. So Criticality is our tool for looking at, based on the location of your isolation valves, what are the smallest isolatable segments of your system, and if something were to happen in each of those segments or whatever subset you choose, what is the impact on your system? So what is the extent of the outage? What is the impact on your customers and on your demands? So this is the tool to help you with that. Just move this out of the way so we can see it, and zoom out here. So the different colors represent those different. So you can see those purple isolation valves there behind. So those isolation valves are forming the boundaries for each of these isolatable segments. So another tool we have available in WaterGEMS is a flushing analysis tool. And this can be used to set up flushing runs and flushing events for both conventional and unidirectional flushing. And so we have both that have been set up in this model. And we're just going to quickly look at one of our unidirectional flushing events here, just to show you chiefly how you can select from the drawing to be able to set this up, and also what the field reports look like when you generate them in ArcGIS Pro. So this is a flushing event where we're going to flow hydrant H38, and we're going to close our isolation valve 934. When you create and set up these unidirectional flushing events, there's a select from drawing tool that you can use to help you with this. And it lets you pick from the drawing what valve am I going to operate, what hydrant am I going to flow, and you can just select those here right out of the picture. This one's already been set up for us, so we're just going to compute this single flushing event and generate a report for it. You can compute them all in a batch if you want to as well. There's a lot of different reporting and tables and output that are available here, but we'll just stick to looking at this one report for this example. So I can do a new flushing event report, field report for this. All right, so the first page of the report just has this legend showing the valves to close are going to be shown in red, a valve that needs to be open shown in green, and our hydrant that we're flushing will also be shown in green. And so we can go here, and it captures the mapping from ArcGIS Pro, the hydrant there in red, the valve there in red that we're closing, and then over here in green, the hydrant that we're going to be operating. And also here in our field report, it shows us what we can anticipate for pressure and flow for that hydrant that we're flowing, and some notes available here for that valve. And then finally, the final actions telling you to reopen that valve once you're done with this flushing event. All right, so that's it for running through some different features and display tools in WaterGEMS for ArcGIS Pro. So for the remainder of today's session, we're going to go through the model building tools, and we're going to go through those in a bit more detail. Model Builder, T-Rex, and Load Builder for creating and loading your model using GIS data. So the first thing we'll look at is as if we were starting a brand new WaterGEMS project within ArcGIS Pro, and we're going to start it using some data that already exists in our GIS. So we'll go through the process of how we can bring in some of that existing data and use it to create our model. So I've just gone to the Windows Start menu here, and I've started up WaterGEMS for ArcGIS Pro. There's also a desktop shortcut for this. And so this will launch ArcGIS Pro with WaterGEMS available in it. And I already have a project set up in ArcGIS Pro that does not yet have a water model associated with it, but I already have some data in here. So as you can see, I've got some background aerial photography here for my map, and I've got a few different data layers here. So I've got my pipes shown in blue, and if I right-click on pipes and open the attribute table, we can see what we have there. So these pipes, the data that's contained in my GIS is the diameter. There's also the roughness, Hazen-Williams C factor there, which I think probably a lot of GIS systems may not have. We happen to have it in this case. It'll work either way. And then we have the material for the pipes. Okay, so we also have some buildings as part of this GIS data, just so where you can see where those are. And we've created some customer meter points here at each of the building locations. And let's go ahead and take a look at that. I'm going to close out of that window. I have some zoom-dependent visibility set up on the customer meters, so I do need to zoom in here, and we'll just wait for those to refresh and appear, so you can see all of those different elements. And as far as what we have for the customer meters, if I right-click and open this attribute table, you can see that we have the flow, which is just the demand at that location for all these customer meters. Okay, so let's look at what we need to do at this point to actually turn this into a WaterGEMS project. So first of all, we're going to go to the WaterGEMS menu and go to it's the WaterGEMS tab. We're going to go to hydraulic models, and we're going to choose to add a new hydraulic model. And we can go ahead and give it a name. And I'm going to call it My System and save it. I have to give it the coordinate system that I want to use, and let me use the search tool here to just help me locate that a little more easily. If I follow the little breadcrumbs down here. So this is going to be, this project's actually going to be in meters. So I'll make sure I select that and click OK. So at this point, what it does is it creates your new hydraulic model files, including a file geodatabase. So that's what you can see here coming into the contents area. So it creates a different layer for each of the different element types that we have or could have in our model. It also prompts whether we want to track changes for the hydraulic model, so we do have the ability to log all the changes that get made, and you can bring those up in a table format and review those if you want to. For this example, we're going to answer no to this question and not do that. Okay, so at this point, we've created the structure, we've created the geodatabase, we've created the model file, but we don't yet have any pipes or any other elements as part of that model. So they still just exist at the moment in our utility GIS. So there is a synchronization process that needs to happen between the two. And, you know, this is appropriate. You know, with a water model, you're often modeling, you know, hypothetical situations, things that don't exist yet, alternate designs and things like that. So we don't have to keep, you know, all of that synchronized into our main mapping system in our GIS. We can just take what we need from the GIS and sync what makes sense, and we make that into a very straightforward process for you. So anyway, what we're going to do now is take that data, those existing pipes and the customer meter data that we've already looked at that exists in our GIS, and we'll go through what does it take to go ahead and bring that into our model file. So we're going to go first of all to a tool called Model Builder. So this is under the Water Tools tab. We can choose Model Builder. And I'll go ahead and create this, you know, as a brand new model builder connection. We can make it go pretty quickly here. You can see all of the different data source types that we support. This one happens to be, we do support geodatabase, file geodatabases when you're working in the ArcGIS Pro interface, but this one happens to be a shapefile format. I'll browse that and get that here. So we do have some data on some of our other node elements and so on. For brevity, I'm just going to bring in, we'll assume we just have pipes. And so I'll grab that one and then also get those customer meters and open that. And then click this Show Preview here. And we'll be able to see the data that we have available. It's similar to what we just looked at when we looked at the attribute table here in ArcGIS Pro. You can see the data previewed here as well. This is just a wizard we walk through. This is actually units are in meters here. We'll go ahead and automatically create junction nodes at our pipe endpoints because we're not bringing those in explicitly. So we have some different options related to how data is, you know, whether new elements are created and or just being updated and so on. I'll just try to keep it pretty simple for now going through this. Okay, so for our customer meter data here for that shapefile, I'm going to say, yeah, when you bring that in, they're going to be customer meter elements within WaterGEMS. And we're going to use a label. This label field is a unique identifier. And then if we wanted to bring in the flow, here is actually going to be the demand. And I believe these units for flow in this case are in liters per minute in our data source. So we'll set that. And for this case, that's all we're going to bring in. We'll just bring in the demands for this example. And then we'll go to our pipes. Once again, we'll use label as the unique identifier, and we're going to match up the diameter here. I believe the diameters are in millimeters in our data source, so we'll set that up. And we can also get the Hazen-Williams C assigned, since we do have that available, and also the material. And then we'll click Next. Now, another thing that we have the ability to do is to save a snapshot of what was the state of the data when we were doing this import right now, today. And this can be helpful to us if later on we're going back to pull in any updates from the GIS into our water model, and it will flag any differences for us, and we'll be able to review those. So, so we're going to let that, let it do that. And we want to, in this case, we're building the system, so we're going to be importing everything. So we'll uncheck this box here, and it will automatically, it's showing us the location where this snapshot will be saved, and we'll just leave the default and click Next. Say yes, we'll go ahead and build the model now, and click Finish. Okay, so we do have some messages here, and what it's really doing is just letting us know, because we only brought in pipes, so we didn't bring in any of our other node elements, that it was having to create those for us at the pipe endpoints, which is what we expected, so that's fine. Go ahead and close out of these windows, and we'll resynchronize the drawing. All right, so it looks like now we've got everything in here. We can see some different pinkish color nodes that got created. So these are some junction nodes and also customer meters that got created here for our system. Now we can go ahead and turn off some of that GIS data, since it's really redundant at this point in the display. So we'll turn off the customer meters and the pipes, and I'll go ahead and turn off the buildings too, just to get our display a little simpler there. And what we're looking at this point then is just what is actually part of your water model at this point. So I was noticing here the appearance of the junction nodes and the customer meter nodes is actually very similar, so I think it would be good to go in and make a little change to that. And I think we'll just go ahead and change the customer meters in this case. Maybe we'll actually go ahead and make them look kind of similar to the choice that we had used for our GIS data set. And then, of course, we can change the properties and make those maybe quite a bit smaller. All right, so now we can see all of those in the system. Okay, so just to take a look and make sure that it looks like all of our data came in okay, we can look at some attribute tables. Now, right now, there's not a lot of data in the attribute tables. It's just really basic, you know, the pipe labels and the pipe lengths. So in order to be able to get any data that we might want to be working with, color coding by, labeling, doing labeling for, anything like that, in this ArcGIS Pro interface, we do have to join our water model tables that have been configured with the data that we want to the attribute tables within ArcGIS Pro. And so we make that very easy for you to do. But first of all, just to take a look at our geotables. So this is just a type of flex table, if you're familiar with the flex tables within WaterGEMS, if you've used it before. So I can bring up, for instance, a pipe flex table. And everything on the right are the columns that are currently in my pipe flex table, and everything in the left are things that could potentially be in it. So you can just, you know, go back and forth and only include exactly the things that you want, and kind of clean up these attributes typically before you would go and do this synchronization. I'm not going to try to do too much with it now. I'll just go ahead and click OK and accept that. And then we can go to the Join Geotables and say Add Joins. Click OK. And this will do not just the one table that we were looking at. It will do all of the different element tables for every type of element at this point. This is something you typically only need to do one time, so it's really something when you're first setting up your model that you would need to do. All right, so now we can go back to our pipe table for an instance and open that attribute table. And we'll be able to see all of these columns here will be a match for that geotable format that we just looked at. So whatever you want to be in here to be able to work with, like any other data that you would in ArcGIS Pro, you just make sure you put it in that geotable, and then the join will take care of the rest for you. So it looks like everything came in okay. It looks like we have our different diameters and our different materials. So it looks like we were successful with our model build process. So we'll close out of that. Okay, so our junction node elements got created as part of this model building process, and they do not yet have any elevations assigned to them. They're all at 0 elevation. Now, if we had had elevations and nodes as part of our GIS data source, then we could have brought that in the same way we just brought in the other data. But we also have some automated tools so that we're able to automatically read in our elevation data from different digital elevation model formats and get those assigned to our junction node. So the next thing we can do is use a tool called T-Rex. It's for terrain extraction to be able to automatically assign some elevation data to all of our node element types. And the file that we're going to use this is a contour shape file, but you can see from the list we support a number of different formats here, including if you're using ArcGIS Pro, some raster and ArcGIS Pro raster and contour formats. The elevation field here is called elevation. I believe the XY units are in feet, and I believe also the Z units in this case are also in feet, but the software will take care of any unit conversions for us that need to happen. And we'll apply this to all of our elements, but we could do a subset of them. So if you had some elements with elevations already assigned and you just wanted to use your DEM data source to assign any missing elevations, we have some workflows that would enable you to do that. And we'll click Next. So it's updating both the junction nodes and the customer meter nodes with elevation data. I do have some features in this model that are actually outside the area covered by my DEM shapefile, so those will not have an elevation assigned. But for the most part, we do see that we did get our elevations in here, and we'll just click Finished to get that finished up. All right, so we can just check to make sure that that came in okay. So for example, on junction, I'll just right-click and choose Attribute Table. And we can see we've got our elevation values in here. So it looks like everything was able to import okay, except for those ones that were, of course, outside of the area covered by our digital elevation model. So we might have to bring in data from a second data source or manually enter some data for those missing elevations. So the next way that we can use GIS data to help us out in getting our model set up is to get the demand data assigned. So if you recall, we brought in our data, and I'll actually use our selection tool here to open the processing, to open the properties. And I'm going to dock the properties over here on the right. So now any element that I select here in the drawing, I'll see the properties for on the right. So we can see that we've already got our data in here for our demands, although I may want to see that in gallons per day rather than gallons per minute when I'm looking here at the demand on an individual customer. We do have the additional tool that's called Load Builder that can help you develop demands from your GIS data and other data that you have on your system if you don't already have these broken out and assigned to your individual customers. And so that tool is Load Builder. So we'll take a look at what Load Builder has available for us. So a common thing you might do is use point load data, and that's if you do have GIS data that's, say, your geocoded customer meters, and what that does is rather than actually, you don't even actually have to import them and include them as part of your water model. You could just assign, allocate the demands from those customer meters to a nearby node. And so we give you a few ways of doing that, either based on a decent polygon or based on the nearest node or the nearest pipe, and then it gets allocated to the nodes at either end of the pipe. So that's one thing you can do. We also do some things with area load data. So there's things like if you know the total flow for a polygon, like it's a metered area or something like that, then we can divide it up among the different junction nodes within that area. And we can divide it up either equally or proportionally by the service areas for the nodes or population information and unit line methods, so a number of things there. Then we also have if you have, say, unit demands assigned to polygons, so maybe you've got a planning or a zoning map with some different land use types with different demands, like how many gallons per day per acre or something like that. We've got some tools that will help you process that data and get that assigned to your nodes. In this case, we're just going to be using this tool in a very simple way to be taking all of those customer meters that we have in here and associating those, the demands of those customer meters to a nearby junction node so that we can use them as part of our hydraulic calculation. And we have a few different ways that we could do that. We can either have service area polygons that we generate for each of those junction nodes, or we can use the nearest node or nearest pipe. So in this case, I'm going to use the nearest pipe method. And then we'll click Next. And so I tell it what is my pipe data layer that I'm going to be using. And it's here in my water features in my geodatabase, so it's that pipes layer that we've been looking at. There. And so we'll assign that so that it finds the nearest pipe, and then it has to allocate the demand from that customer meter to the nodes at either end of that closest pipe. And so we choose here how we want to divide that flow between the nodes at either end. So in this case, maybe we'll just do it to whichever node is closest to where that customer meter is. And then what is our node layer that we're assigning these demands to? We'll choose that here. And then our customer meter layer that we're working with. Some customer meters, if you already had a node associated, we don't have to do it twice. In this case, we actually will be doing all of them. The other thing that you can do is you can create some additional drawing elements if you want to. So we can actually explicitly draw a lateral and a tap where these customer meter nodes connect into the pipe. And let's go ahead and let it do that. Okay, so now we can preview our results and see what customer meter got assigned to which element. We'll go ahead and click Next, and we can label this load builder process in case we ever needed to repeat it. And we'll update our existing base demand alternative and finish. Okay, so now we've got our customer meters assigned, and we'll close out of this and close our load builder window. We'll let it synchronize the hydraulic model. All right, so now we have our model with our taps and laterals and attaching our customer meter nodes, and all of this refreshed in the drawing. One thing to note is that these taps don't actually split the pipe. So if I go and select this single pipe here, you can see there's a continuous pipe run all along where it's highlighted. So even though the taps tie in to these locations, they don't actually cause you to have more pipe segments in your model. Okay, so a final thing I'll touch on as part of our model building and synchronization discussion is what happens if you are wanting to go back and some modifications, some updates, say, have been done in your city's GIS system on your pipes and other elements in that affect your water model, and how then do you go back and make sure that you bring those updates across into your WaterGEMS model. And just to kind of make this drawing a little bit simpler to work with, I'm going to go ahead and turn off the customer meters and taps and laterals. So we'll just look at our main water piping in here. All right, so for the moment, I had turned off the original pipes shapefile that we had open that we'd used to create this water model originally. So now, just for illustration, I'm going to go ahead and turn off my junctions and my pipes that are my water model pipes and turn back on those shapefile pipes. And let's go ahead and edit some of this data about these pipes and then look at how we could make sure that we would pick up that data in our water model and what the process is to do that. So I'm going to come out here to this pipe on the end and select this. Let's select this pipe right here. And we'll right click and go to its attributes. All right, so we can see the pipe's got ID, diameter, and so on. And so what if we were to change that diameter to 600 millimeters, for instance, and then click apply. All right, so again, this is changing in our original GIS data source. Okay, so what happens if down the line then I want to make sure that I pick up any changes that have happened in my GIS and get those into my water model? So we're going to be going back to our model builder tool. And we have, this is the original model builder connection that we had set up. And we can reuse that connection. Instead of just synchronizing that data to build our model, the first time, we can push that data back out and go from the model to our data source if we want to, or in this case, just make sure that we capture the updates. So you just right click, and if we already had it configured exactly the way that we want it, we could just hit sync into model right here, and it would sync any of those new changes across. But instead, what we're going to do in this example is go ahead and edit this connection so that we can get in and use the snapshots feature to be able to compare and flag any differences between the current state of the model in our GIS and what it was when we previously synchronized it. So we can see it's flagged for us, that difference in pipe diameter, and we can choose to accept or reject that change from the GIS with the checkbox there. But we'll accept it and go ahead and move forward with this synchronization. All right, and now let's go in and take a look to see that the change in the pipe diameter did make it back into our water model. So we'll go into our water model pipe properties. First of all, turn off that shapefile layer and turn back on our water model pipe layer. And then select that pipe in the drawing to see its properties. And here we can verify that we do see the change in diameter. And if we want to make sure that we compare it in millimeters, since that's how we entered it, we can just change it over to millimeters. And there we go. All right, so that sums up our presentation. I'm just trying to, get this slide back up here so you can see it. So this is what we covered. We did the general overview of WaterGEMS, and we did the demonstration of WaterGEMS for ArcGIS Pro, a variety of features with particular attention to the model creation side of things. We do have a Q&A panel available, so if you do have any questions about this, please feel free to enter your questions, and I will do my best to answer them for you today. I think we have a few minutes left for this if anyone would like to do that. Okay, it looks like I'm not seeing any questions right now. Of course, I'll look and see if we get any after the fact, but just thanks so much for everyone coming today. I guess that will do it for our webcast. Thanks so much.